I'm calling this 9.3 extension because it's not in the textbook. So it's something that we want you to have, like some kind of like, oh, I've seen that before, or yeah, I've done that before. And what we do tomorrow, the inverse trig applications, that's actually something that you have done in geometry. So you see it again in Algebra 2, and then you see it again next year in your trig chapter. What I'm showing you today is probably new, something you didn't do in geometry, but it builds off really nicely from what we did on Friday. And it's really helpful in Algebra 3 and pre-calculus when you want to start solving equations. Okay, so to kind of have an idea of how this works, this is great. Now, what we want to do here is basically find angles. So what I asked you to do on Friday and like that number 4 on the quiz, and really I guess like number 1 and number 2, I previously have been asking you to find ratios. So like when I would say, let -3, 3 be a point on your terminal side, you would draw a right triangle, label the side, -3, 3, find the radius, and then do opposite over hypotenuse, adjacent over hypotenuse, or maybe you're thinking about like y over r, x over r. But you're giving me an answer that is a ratio. And like what you did on Friday, you would draw those special right triangles, right? 1, 1, square root 2, 1, square root 3, 2, and you would do still y over r, x over r, those types of things. Okay. Now I'm going to ask you to find the angle or angles. So notice in the directions, it's really important that you pay attention to this. It could be that there is a single angle answer. It could be that there are multiple angle answers. That's why the S is in parentheses. And I want you to give it to me both ways because it will help. What we're going to do today are going to be special angles. It will help you build the connections. Like 180 is pi. 150 is 5 pi over 6. Okay, so hopefully like as you do this assignment, you'll start to know those special angles in degrees and radians better. Okay, so it says where theta is between 0 and 360 and 0 and 2 pi, express your answers in both degrees and radians. So maybe you'll just have like 2 answers, 1 in radians and 1 in degrees, but it's the same angle. But if you have like 2 angles that work, then you're really going to be writing down 4 things because you got to write them in degrees and then you got to write them in radians. Now, before we do the example, I want to talk really quickly about the setup here. So, do you see how we have a less than or equal to, and then we have just a less than? Okay. This means include 0 degrees, not 360. And if you think about 0 and 360, those 2 angles are coterminal. They're the same angle, aren't they? Just on the positive x-axis. Okay, so I don't want you, if you say that it's that angle over there at the positive x-axis, I want you to say 0. Don't say 360. And the same thing for 0 and 2 pi. Include 0, not 2 pi. So if you want to answer 2 pi, answer with its coterminal 0 because that's included in the notation. That's all that's saying. Okay, so let's look at this example. Cosine theta equals square root 3 over 2. Well, hopefully, after our discussion on our homework, and you heard the answers that I was reading as I was going through those numbers 1 through 15, hopefully you kind of recognize this. Yeah, I've seen sines and cosines that are this ratio, square root 3 over 2, from a special right triangle, right? Okay. So here's what you want to do. Think backwards. If my cosine is positive, square root 3 over 2, which quadrants could I potentially be in? Luke? 4 and 1, right? All students take calculus. So everything is positive in quadrant 1, and cosine and its reciprocal are positive in quadrant 2. So we're not looking in quadrant 3, and we're not looking in, quadrant 2, and we're not looking in quadrant 3. Okay. Now, what I would suggest you do then is for the 2 viable quadrants, draw a right triangle that's part of a bow tie. That's what my right triangles would look like in quadrant 1 and 4. Do we agree? Okay. In order for cosine to be square root 3 over 2, think about how you get the ratio for cosine. What do those 2 numbers represent for cosine's ratio? You might be thinking adjacent over hypotenuse. How else might you think about a cosine? Or you might be thinking x over r. Either way, remember Hannah's question at the beginning of class about where her angle is? Your theta is always right here at the origin. So if you're thinking about it as adjacent over hypotenuse, the adjacent side to theta is x, which makes sense. And the hypotenuse is that side opposite the right angle, which is our radius, so 2. Okay. And the other side must be 1. So if you kind of fill that in, we know this side is that other side 1. So we have a special right triangle right there with side lengths 1, square root 3, 2. Obviously, it's a 30, 60, 90 triangle. We have to figure out which angle theta is. So is theta 30 or 60? Why do you say 60?
Because special right triangle rules, the 1 is, or the angles is facing the higher number, which is facing the 1.
What's higher? 1?
Yeah, instead of square root of 3. That's just
what is the square root of 3? Why is it bigger than 1? How can you know the square root of 3 is bigger than 1?
Because it's across from, it's opposite of the 90 degree angle. And one's across from the 30 degree angle.
Okay, but like in terms of just like number sense, why is the square root of 3 bigger than 1?
Because 1 times 1 is 1. So you can't really.
Yeah, 1 squared is 1, and the square root of 3 squared is 3.
Oh, okay. Yeah. I also, like, whenever people are having trouble with radicals, I always say, you know, like, if you don't know what the square root of 3 is, but you're trying to, like, just estimate it, like, what 2 perfect squares are right around 3? 4 and 1, right? 1 is lower and 4 is higher. And we do know the square root of 1 is 1 and the square root of 4 is 2. Therefore, the square root of 3 is in between, and I know it's 1.73. So square root of 3 has always been bigger than 1. So Jacob, does that then change your answer? Okay. So Kaylee knows her special right triangle. She's just saying across from 30 is 1. Across from 60 is square root 3. And then, of course, opposite the 90 is 2, because that's the longest side. 2 is greater than 1.73. Okay. So then which angle is this theta?
30.
That's 30. Okay. So in quadrant 1, that's just the angle that it is, right? 30. Now, what we're saying here in quadrant 4 is that theta prime is 30. Its reference angle is 30. So what would that angle actually be in quadrant 4?
Negative 30. Oh, positive. Positive angle. Oh.
Between 0 and 360 and 0 and 2 pi.
Oh yeah.
Okay, so then you want to find your actual angle. 360 minus your reference angle is 330. Okay. So now we know 30 degrees, and we know 330 degrees, and then we want to get them as radians as well. So what angle is radians for 30? Pi over 6. I always remember, like, I know that's hard. You know, like, you can always convert times pi over 180, and then 30 over 180 is 1/6. Or I just remember 3s and 6s mismatch. Now, you could do a conversion for 330. I'm going to move this slide shade so I can move it down. You could do a conversion for 330, but I would think about it like our reference angle work backwards. Instead of doing 360 minus 30, let's do 2 pi minus pi over 6. Because 1 full revolution would be 2 pi, and we're in that fourth quadrant. So we're 1/6 short of that. What's that? 11 pi over 6. This is 2 pi over 1. So just double the denominator here. This is 12 pi over 6 minus pi over 6, which is then 11 pi over 6. So 330 is 11 pi over 6. 30 is pi over 6. There's really only two angles, but we've listed them in degree and radians. Okay, so we're working backwards. Figure out which quadrant it's allowed to be. Draw the triangle and label the sides. And then find the angle using reference angles backwards. Okay, so we're going to do another one. Darby, make sure you get your assignment. Let's do cosecant of theta equals -2. Okay, now you probably don't know cosecant as well as you know its reciprocal. What is its reciprocal? Okay, so usually when I see a reciprocal one, I just revert it back to the one I know better. Because I feel more comfortable with sine for some reason. Right? So sine theta is -1/2. Okay, think about where you're allowed to be so that sine theta is -1/2. All students take calculus. It's positive in quadrant 1 and 2, so we must be in quadrant 3 or 4. Okay. Draw some triangles. Part of a bow tie, right? Now, label the sides according to the ratio. You can do it either with cosecant, then you got to think about it as -2/1, or with sine, that's opposite over hypotenuse. Or you might think about it as y over r. Okay. So our angles are here at the origin. I know y is -1 and r is 2. How did I know y was negative and r was positive? I didn't just guess.
The axis.
The axes, what do you mean by that?
So when you're going to the left on the x-axis, it's going to be negative, and when you're going down, it's going to be negative.
If I'm going down, which that's what that picture is showing, going down, it's negative. And what did we always say about r? R is always positive. So it has to be -y, -1, +2. Okay, what does that mean this missing side is? Negative. Yeah. negative radical 3, and then a positive radical 3. Okay. Okay, so which angle is theta, like just 30, 60, 90, 45, 45, 90? You can choose from 30, 45, or 60? 30. Opposite of this angle again is that shortest side 1. So that means these are 30-degree reference angles. We already know this one in quadrant 4, don't we? Okay. So we know theta is 30, or I'm just going to say theta is 30. Well, I guess I could say theta prime is 30 degrees. Okay, theta prime is 30. So in quadrant 4, we know that's 330 and 11 pi over 6. Because 360 minus 30 is 330, and 2 pi minus pi 6 is 11 pi over 6. How will we find the reference or the actual angle in quadrant 3? 180 plus 30. Isn't that angle always the overflow of 180? Okay, so you got to think backwards. We used to take that angle minus 180 to figure out what the overflow is. Now we know the overflow is 30, so we're going to add that 30 back to 180. So we can do 180 plus 30 is 210 degrees. How could you do that with radians without converting? Half of that circle is pi radians, and we have an overflow of pi 6. Okay, so we know that the reference angle is 30 or pi 6. So we're really just doing pi plus pi over 6. 1 and 1/6, which is 7 pi over 6. Okay, now I know this can be like a little bit like, say what? But the benefit of you working backwards here is really, really awesome for like getting better at these special angles, both in degrees and in radians. Because you keep adding and subtracting from 180 or 360 to get the thing you know. I think I have one more that I at least want to do. Got a few more on this one. Can we talk about this tangent one at least? This is a good discussion to have. And then I'll give you your homework assignment before the bell. When it says the tangent of theta is undefined, what must have happened with your tangent? There must have been a 0 in the bottom, right? Okay, so what is tangents opposite over adjacent, or y over x? And so you guys are telling me that it had to be something over 0. So when would your adjacent side, which this doesn't seem to make as much sense as x, be equal to 0? When you're on the y-axis. Right? At both of these points, you would have 0, and like I usually put in a -1 and a +1, but you could put in any number right there. 0, something. I'll put in 1 and -1. So what angles are those? 90, 270, in radians?
Pi over 2.
Pi over 2?
3 over 2.
3 pi over 2. Because this is 1 pi, this is 2 pi, so this is 1.5 pi. So if you had trouble on number 2, the quadrantal angle on the quiz, remember those points? Like you can just pick a point anywhere on the axis where the angle is. And it doesn't have to be 1 or -1, but I just choose those because those are easy. So the radius on that one is 1. Okay, now I need you to listen very carefully On this homework assignment, you're only doing the front side,
Oh.
finding an angle using reference angles. The back side, inverse trig application, that's for tomorrow, but I didn't want to have you have like a million papers for these worksheet cards. So you're only doing front side. If you have to start looking up inverse trig to the back, you don't have to do it. Front side only. Angles in degrees and radians, most of them will have 4 answers, although it is possible to have only 2 in radians and degrees.